Assalamualaikum and selamat datang to Professor Burhan and others that watching. So in this video, we will be presenting about our neural network project with titles of prediction of backpack using artificial neural network. So before I proceed with our project details, let me introduce to my team member. My name is Nur Fariha. In my team, we have Muhammad Adam Hafizi, Nawad Izzah, and Amir Faiz. So first and foremost, our project is about the prediction of backpack using artificial neural network. So this project will implies the feed-forward neural network, which is the multi-layer perceptron, where it consists of 3 layers input. The first one is the input layer, the second one is a hidden layer, and the third one is the output layer. So this technique will be using the TensorFlow framework in our project. So this project, as I mentioned, is about the prediction of condition of the brake pads and their replacement. So this system will be useful for business to utilizing their maintenance procedures, improve safety, and also their financial saving. So next, we go to the description of the dataset, where our dataset consists of 338 rows about the brake condition with 5 columns of attribute, which is the total distance until it wants in kilometer, brake pad hint, 1, 0 is for not 1, and 1 is 1, and then the wear rate as Z, and also the brake status in probability value in range of 0 until 1. However, the original dataset that we received has minimal sets of data. So we do some changes towards the dataset where we added some dummy samples to the dataset to increase the rows until 338 rows. So this dataset will be useful in creating a model that could estimate the condition of brake pad of the vehicle. So this is the sample of our dataset, which is we have 5 columns. The first one is worn, either 1 is worn and 0 is not worn. The second column is total distance until it's worn in kilometer. The third column is about the brake pad heat, and the fourth column Z is the wear rate, and the last column is the brake status in probability value in the range of 0 until 1.
Next, for the flowchart, we import the libraries such as pandas, numpy, and tensorflow. Then we read the CSV file and do the pre-processing to the data. And next, we split the data to training and testing data and normalize the feature before we start to build the ANN model, because we don't want any feature to dominate the learning process. Then we train the model and test the model to print and to get the prediction output. Then after that, we calculate the accuracy and print the accuracy. Next, for the learning process, this model uses feed-forward neural network trained with backpropagation. First of all, we need to import necessary libraries such as pandas, numpy, and tensorflow. TensorFlow is a library that is used to build the neural network model. After that, we load the dataset break modifieds.csv into the pandas data frame. After that, we do the pre-processing step before we going to split the data into 80% of data for training and 20% of data for testing. After that, we do the feature normalization to ensure zero mean and unique variance to avoid any single feature to dominate the learning process. After doing the feature normalization, we build the neural network model. This model has 3 layers, which is input layers, then layer 1 and output layer. The dense layer 1 has 16 neurons and use the rectified linear unit as a activation function. and the output layer has one neuron for binary classification, either 1 or not, and it uses sigmoid activation function. The model is compiled using the Adam optimizer and binary constantrophy loss function. The model was trained by using backpropagation that facilitated by fit function under TensorFlow framework to compute the weights and bias during training. The model is trained for 50 approach, which means it going through the dataset 50 times, and it will update the weight after 32 process. After the training, the model is tested on the testing data using a threshold of 0.5 for converting probabilities into binary prediction, either 0 or 1. The accuracy of the model's prediction is calculated using the accuracy function under scale length framework.
Next, I'm going to talk about the learning step by step. The first one is to import the necessary libraries such as NumPy, Pandas, Matplotlib, and we also use sklearn, which is for testing and also training the data, and also TensorFlow, which is to build the ANN. The next step is to read the CSV file using pd.read.csv and store the data in Pandas data frame. The third step is to inspect first few rows of data frame using the f.head. This is to ensure that we can see all the attributes of the dataset. The next step is to preprocess. What we did here is we replace commas in the kilometer column and we also convert it to float to ensure that it is suitable to be used later on. And then the next step is to split data into features X and target variable Y using the f drop and also the f column name. Sixth step is to split the data into training and testing dataset. So we split our dataset 80% for training, meanwhile 20% of the whole dataset is used for the testing. Seventh step is to initialize feedforward model using sequential function under TensorFlow framework. 8 is to normalize the input feature. So what we did here is we use standardization by subtracting the mean and also divide by the standard deviation. This is done separately for the training and also testing sets. The ninth step is to build ANN model by using sequential function under TensorFlow framework. As you can see, based on the code, the model architecture is defined by adding layers to the model by using the add method. The first layer is a dense layer with 16 units and the value activation function. The input shape is specified as the number of columns in the training dataset. The second layer is also a dense layer with 1 unit and the sigmoid activation function. This layer produces the binary classification output. And step is to train the model using training dataset by using the model.fit. Next step is to print data, which include features X-train and target variable Y-train, so that we can see all the features and attributes of the data. Next step is to test the model by predicting target variable for testing data using model predict, and we will be storing the prediction in YPrep. The second last step is to print prediction output, while the last step is to calculate the accuracy using accuracy score. Accuracy score represents the proportion of correct prediction. The reason why we calculated the accuracy is because we want to measure the performance of this model. Next, I'm going to talk about how analysis was conducted. The first step is data preparation. We write data set and store it in Pandas data frame named df, and then we also remove the commas in km column of data frame and convert the values to float to ensure that the data is in suitable format for analysis. The next step is data splitting. We split the data into features X, target variable Y using the f draw and the f column name, and we also drop the one column from the data frame to get the feature set. And then we split the data into training and testing data set. Training is 80% of the whole data set, meanwhile testing is 20% of the whole testing. Next, I'm going to talk about how analysis was conducted. The first step is data preparation. We create the data set by using pd.read_csv, and then we store in Pandas data frame named df. We also remove the commas in kilometer column of data frame and convert the values to float to ensure that the data is in a suitable format for analysis. And then data splitting. We split the data into features X and target variable Y. And we also drop the one column from the data frame to get the feature set. And next, we split the data into training and testing data set. Training is 80% of the whole data set, while testing is 20% of the whole data set. The next one is model image. initialization and training. We initialize the feed-forward model using sequential function, and we train the model on training data using the feed function. This is to allow the model to learn the patterns and relationship between features and target variable by using the underlying backpropagation under TensorFlow framework. And then data exploration. The training data consisting X-train and a corresponding target variable Y-train is printed to observe values and structure. As you can see, we have 4 columns, which is KM, heat, Z, PR. PR is basically whether the breadpath is 1 or not 1, and we will round off the values. As you can see, the values for breadpath 16 is 0.627866, and we round off the value to 1. And for the negative value, we will round off the value to 0. And then testing and prediction. The testing data including the feature, X test, and the target variable Y test is printed to examine the values and structure of the testing set. Then we predict the target variable for testing data using model predict through the train model. This is our testing data, which is consists 20% of our whole data set. And then this is the prediction output. Last one is model evaluation. In order to evaluate our model, we calculated the accuracy, and based on the output, the accuracy of our model is 0.89705. This is done by comparing the predicted values of Y-pred and the actual values Y-test. And then we also have classification report and confusion matrix to summarize the model's performance and to help us to see the overall model's performance by giving insights of how the model distinguishes between the positive and the negative classes. So I'm going to talk about the classification report. First, we have the precision for two classes, which is class 0 and 01. For class 0, the precision is 0.86, which means that out of all the instances predicted as class 0, 80% is actually from class 0. This is the same for the class 1, which is 94% of the whole instances predicted are actually from class 1. And then we have recall. Recall is basically the same as precision. And then we also have the F1 score, and the last column is support. Support means that there are 33 instances of class 0 in the test set for class 0, and for the class 1 we have 35 instances of class 1 in test set. And then we also have the accuracy. The accuracy of our model is 90%, which means that the model correctly predicts the class of 90% of the instances in the test set. And then for macro average and weighted average, in our case the weighted average and for the macro average, recall and F1 score are all 0.90. And then the last one we have confusion matrix. In summary, for our true positive, 31 instances were correctly predicted as class 0. For false negative, 2 instances that should have been predicted as class 0 were incorrectly predicted as class 1. And for false positive, 5 instances that should have been predicted as class 1 were incorrectly predicted as class 0. And the last one is true negative. 30 instances were correctly predicted as class 1. For our confusion matrix, it is worth to note that our positive class is 0 while the negative class is 1.
Next, we will present the business intelligence model. We start with a diagram representing the neural network, with the input layer on the left consisting of the features such as watt, kilometer, heat, bias, and speed, and the output layer on the right representing the predicted breadpath condition. During the forward pass, the input features are propagated through the layers, with each neuron computing a weighted sum of inputs, applying an activation function, and passing the result to the next layer. To evaluate the network's performance, we compare the predicted breadpath condition from the output layer with the desired output. In the backward pass, we propagate the error information from the output layer back to the input layer, starting with the computation of the error gradient from each neuron in the output layer. Moving backward, we calculate the error gradients for the neuron in the hidden layer using the chain rule, which takes into account the error gradients from the subsequent layer and the weights connecting the neuron. With the error gradient known, we update the weight of the connection in each layer using an optimization algorithm like gradient descent. The weights are adjusted in a direction that minimizes the error and improves the accuracy of predicting the breakback condition. This process of forward pass, error calculation, backward pass, and weight update is repeated iteratively for multiple epochs, allowing the network to gradually refine its weight and improve its ability to predict the breakback condition based on the input features. And the conclusion is this project applies predictive analytics and machine learning to prevent maintenance for large truck brake pads. It develops a model that forecasts brake pad replacement using data from the IoT sensor and SPY-ML. By proactively addressing maintenance needs, this strategy improves safety, reduces brake failure, and minimizes downtime. The project showcases data-driven decision-making for optimizing maintenance plan, leading to operational effectiveness and cost saving for vehicle management businesses. That's it.
Next, for the demonstration, for the coding, we use Jupyter Notebook as the compiler under an Anaconda Navigator. First of all, we have to import necessary libraries. From this, we can see the most important libraries is NumPy, Pandas, sklearn model to split the data into training and testing, and to calculate the accuracy. And we import TensorFlow framework to build the ANN model. Okay, after that we have to load the dataset and store it into Pandas data frame, and we print the head of the data to see either the data we load is correct or not. After that, we do the pre-processing, which is we convert the string data type into float data type. After that, we split the data into feature, which is X, and target variable is Y. For the X, we drop the one column because we just want the others feature. Next, we split the data into training and testing data. And before we build the ANN model, we normalize the input feature to make sure there is no any feature that will dominate the learning process. After doing the feature normalization, we build the ANN model using sequential function under tensor framework. From this code, we can see we have two layer, which is dense layer 1. In dense layer 1, it have 16 neurons and use ReLU rectified as activation function. And the dense layer 2 is the output layer. It has one neuron only and use sigmoid activation function. After we train the model, we have to compile the model using Adam optimizer and binary constant as a loss function. Next, we train the model. For the training, we run the process 50 times and the batch size is 32. After train the model, we print the training data, and this is the training data. And we print the testing data, which is this is the testing data. After print the testing and training data, we test the model and print the prediction output. This is the code where we test the model, and this is the prediction of the model. After print the prediction output, we calculate the accuracy, and then we get 0.897059 as the accuracy. And to see the classification, we do the confusion matrix to see the classification precisely. After doing the confusion matrix, we print the classification report to see the precision, recall, F1 score, and support.